ChatGerry, RPP Proxy and the Perspective of Cardiac Mechanical Loading Either Stroke, number 1581, VPT 117, March 26, 2026, Gerald C. Shu, Eclairum Foundation, Category Stroke, CVD. Cardiovascular Mechanics. Introduction. In this study, I looked at how hard the heart works over time using a simple measure called RPP rate pressure product. RPP combines heart rate and systolic blood pressure. RPP equals heart rate x systolic blood pressure per 100. This equation reflects how much mechanical work the heart must perform to pump blood through the body. I analyzed his sets of data. 1. A long-term 9-year dataset from 2018 to 2026, showing my usual heart workload pattern. 2. A focused 18-month dataset covering 9 months before my stroke and 9 months after my stroke. The goal was to see whether heart workload showed any clear pattern related to the stroke event, and whether RPP gives more useful information than heart rate alone. The heart as a pump. From an engineering viewpoint, the heart works like a cyclic pump. Every heartbeat must generate enough force to push blood through the arteries. The workload of the heart depends on two main factors: how fast the heart beats, heart rate, how much pressure the heart must push against blood pressure. If either factor increases, the heart must work harder. When heart rate and blood pressure are multiplied together, we obtain RPP, which reflects the mechanical workload of the heart. RPP does not diagnose disease, but it helps us understand how much mechanical stress the heart experiences over time. What the 9-year data shows: over 9 years, my RPP values stayed within a relatively narrow range. Average RPP was about 65, with most values between 62 and 68. This means my heart workload stayed stable for many years. From a mechanical perspective, this looks like a stable operating zone, where the cardiovascular system keeps returning to a balanced condition. There is no sign of steadily increasing heart workload over time. This is a positive sign. However, RPP alone does not fully describe blood vessel condition. Blood vessel stiffness is better reflected by pulse pressure, the difference between upper and lower blood pressure numbers. Therefore, stable RPP suggests stable heart workload. Pulse pressure helps evaluate vessel elasticity. Both are important. What the 18-month stroke data shows: during the 18 months around my stroke, RPP showed a noticeable peak near the stroke date. After the stroke, RPP gradually returned toward the previous stable level. My average RPP during this period was about 68, slightly higher than the 9-year average of 65. However, the increase was modest and still within the overall range observed in earlier years. This means my recent stroke was not caused by an extreme or abnormal jump in heart workload. Instead, the stroke appears related to a temporary increase in combined stress on the cardiovascular system. Importantly, heart rate alone did not change very much, but when heart rate interacted with blood pressure, the combined workload reached a peak near the stroke period. This shows an important physics idea from simple arithmetic operations of multiplication. Similar to Newton's law of motion, where force equals mass multiplied by acceleration, or F equals mxa. Multiplication creates amplification. Even small increases in blood pressure can significantly increase heart workload when combined with heart rate. This explains why heart rate alone cannot represent total cardiovascular stress. Why TSI is more complete than RPP. RPP includes only two factors: heart rate and blood pressure. It mainly reflects how hard the heart works as a pump. However, stroke risk depends on more than heart workload alone. It is influenced by systolic blood pressure, SBP, diastolic blood pressure BBP, and average blood sugar EAG. These factors affect blood vessel condition, circulation quality, and long-term body damage. For this reason, I developed TSI Triggering Sensitivity Index, which combines these three interacting factors into one simple equation. RPP measures how hard the pump works. TSI reflects the overall system condition, including the pump, the blood vessels, and the blood condition. Therefore, RPP equals secondary indicator, TSI equals primary indicator. Both are useful, but TSI provides a more complete picture of stroke, heart disease, and memory decline risk. Why heart rate matters more in seniors: as people age, blood vessels gradually become less flexible. When blood vessels become stiffer, the heart must pump harder to push blood through the body. Because of this change, blood pressure becomes more important than heart rate alone when evaluating how hard the heart is working. In younger people, changes in heart rate often drive changes in workload. In seniors, however, the pressure inside the blood vessels plays a larger role. My data show that heart rate itself remained relatively stable, but when combined with blood pressure, the total workload on the heart increased near the stroke period. This reflects the natural aging process of blood vessels and helps explain why blood pressure control becomes increasingly important with age. In a young body, the pipes are like rubber hoses that stretch. In a senior body, they can become like metal pipes that don't budge, forcing the pump to work much harder just to move the same amount of fluid. Energy analysis shows 3 factors working together. My analysis shows that 3 factors contributed almost equally to the overall condition of the system. Pulse pressure, mean pressure, and blood sugar each contributed about 1/3 of the total effect. This balanced pattern is important because it shows that stroke risk was not caused by a single extreme problem. Instead, several moderate conditions worked together over time. Blood pressure alone was not the only cause, and blood sugar alone was not the only cause. The results suggest that chronic disease often develops when multiple moderate problems interact and gradually create damage over many years. The key message is simple: several moderate issues, when combined over time, can eventually lead to serious health outcomes. Movie versus snapshot. Most medical exams provide only snapshot data, which shows one moment in time. However, disease usually develops slowly over many years. When we use long-term data, the health condition becomes a movie instead of a snapshot. This movie shows how blood pressure, blood vessel condition, and blood sugar influence each other over time. Seeing the full movie helps us understand that stroke and heart attack are usually not a sudden random event, but more often the result of gradual damage developing quietly in the body over a long period. Conclusion: the comparison between the 9-year data and the 18-month stroke-related data shows that overall heart workload remained fairly stable across time. However, a temporary increase appeared near the stroke period when heart rate and blood pressure worked together to raise the workload on the heart. Heart rate alone did not change very much, but when combined with blood pressure, the total workload became higher. This shows that combining factors gives a clearer picture than looking at one factor alone. RPP helps us understand how hard the heart is working, while TSI helps us understand the overall body condition affecting stroke risk. Together, they provide a clearer and more complete view of long-term health risk. Epilogue: in this article, I treat the heart as a cyclic pump and the vascular system as a complex piping network. Most medical studies rely on snapshot data, but a snapshot cannot show how damage develops over time. Using longitudinal data, the biomedical system becomes a dynamic movie instead of a still snapshot. This biophysical movie shows how pulsatile pressure (PP), steady pressure (MAP), and metabolic load interact continuously through the multiplication-amplification effect. Similar to flow and stress in a real-life engineering piping system, this dynamic view makes the stroke mechanism much clearer and physically understandable. Disclaimer: I write this paper not for fame, but to share what I have learned so others can understand their health, prevent disease, and live longer, healthier lives. This content is for educational reference only and not medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered or republished as your own. All rights belong to the author. Gerald CHSU. X format. Stroke risk is a movie, not a snapshot. My heart rate looks stable, but the combined effect of heart rate and blood pressure reached its highest level before my stroke. Several small problems can build up quietly over time. Watch the long-term movie of your health, instead of waiting for a sudden event. If you want more information, please press here https://www.youtube.com/@ChatGerry. This content is provided for educational reference only and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to the author, Gerald C. Shu.